Okay, some more problems from section 9.2. This is number 24, and it says the Maclaurin series is given. Find f prime of 0 and f, the 10th derivative, is 0. So, first of all, if you take the derivative of this is just going to be 0, 1 over 2 factorial, 2 over 3 factorial x, 3 over 4 factorial x to the second, and you can get the general form. This is the derivative, or this is the function, so if we take the derivative, it's n x to the n minus 1 over n plus 1 factorial. And if we put 0 in for f prime of 0, all of these will have a x value in there that will make it a factor of 0. So all these will zero out, so you just have 1/2. So that was pretty easy. We want to find the 10th derivative. Well, if you look at this, what's going to happen, I just kind of worked out one of them, and you saw when you took the derivative, you got 1 over 2 factorial, 2 over 3 factorial, 3x squared over 4 factorial, etc. And if you work this all the way out, and you use this derivative form, for the 10th derivative, you would have 10 x to the 9th over 11 factorial. So that would be the derivative. Now, if you keep taking the derivatives, what happens is these terms you zero out. In other words, the first derivative, the 1 zeroed out. If I took the second derivative, this would zero out, and then I'd have 2/3, etc. And each time I would be taking the derivative. If we look at the 10th term over here, then if I took the second derivative, I'd have 10 times 9, x to the 8th. Then 10 times 9 times 8, x to the 7th, etc., etc., etc. And I would keep going, so you have to kind of visualize what's going to happen with this. So by the time you get down to the 10th derivative, you're going to have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And your x will be the last one. The 10th one will be all this times x and x, and then that would be your 9th derivative. Then when you take the 10th derivative, you're going to get the 1 there. All over 11 factorial, because 11 factorial is going to stay. That's not going to change. All right. So I hope you can see the pattern. In other words, the next derivative I take would be 10 times 9, x to the 7th. And then the next derivative would be 10 times 9 times 8, etc. Okay, so you would end up with something like this. So hopefully you can kind of see how this would work out. Then you kind of have to kind of visualize what you're going to do. Now, this is like 10 factorial over 11 factorial. Now what happens to the other terms? Well, these are all going to have x's. All right, so when I take the 10th derivative at 0, all these will zero out like they did up here for the first derivative. So all these will zero out, so this is all you're going to be left with on the 10th derivative. Now that's the same thing as 10 factorial, and this is the 11 factorial we had from the 10th term. And if I had a little bit more room, I probably would show you several derivatives so you can see how this would be working. I hope you kind of followed what I said when I said 10 times 9 times 8, x to the 7th, etc., how that works. Okay? Anyway, so this is 10 factorial over 11 factorial. But 10 factorial, 11 factorial is the same thing as 11 times 10 factorial, so the 10 factorial cancels, so you end up with 1 over 11. So that's kind of tricky, but it does work out. So think about that and how those derivatives work. And you could try it. You could try this as the first derivative. You could see what the second derivative would be, and just follow this term and the third derivative and see, and then you'll see that you're going to get down there eventually. Okay, the letter B part. Let G equal x times f of x. Write up Maclaurin series for G of x, showing the first 3 non-zero terms and the general term. So I'll take, there was my f of x up here, and if I multiply it by x, I get x squared over 2, x to the third over 3, etc. And if I multiply that by x, that's going to be x times x to the n would be x to the n plus 1, and that's still going to be over n factorial. And if we take this to the next term, or if we look at the previous term, if I subtract 1 from n plus 1, I get x to the n over n factorial. And so that was the B part. But the C part, write G of x in terms of a familiar function without using series. Well, this is E of it. this is e to the x, right? We know that, and it looks very similar. X1 plus x squared over 2 factorial plus x to the third over 3 factorial, etc. So my g of x, and they want you to write g of x in terms of a, let me see over here. It says write g of x in terms of a familiar function without using series. Well, this is e to the x, and this is g to the x, which is the x times f of x. So it looks exactly the same as e to the x, except e to the x has a 1 and this doesn't. So if I want to write g to the x, I can write e to the x and I can just subtract the 1. In other words, if I take my e to the x and I subtract the 1, this is e to the x. If I subtract 1, what do I get? I get g of x, which is, of course, x times f of x. So it would just be e to the x minus 1. E to the x, if you take e to the x minus 1, what do you get? This. That's pretty much all they want you to do. Okay, hope that makes sense. Take a look at it. Think about it. Try to make sure you understand all these, because these are very good conceptual problems for what we'll be needing to know on Taylor series and the derivatives.